you have seen before, but we're going to get more in depth with it than what you saw in geometry. So the word trigonometry literally means triangle measure. So we are going to be talking about all different measures of triangles, angles, and sides. Specifically, we're going to spend a lot of time on right triangles, which are what they sound like, triangles containing one right angle, which of course is 90 degrees. Okay, so we have 6 trigonometric ratios, which are relationships between the sides of a triangle, of a right triangle. That can help us find missing sides and angles in triangles. So we have our 6 trig functions, our 6 trig ratios. We're going to start with this sine, cosine, tangent. So sine, cosine, tangent. And then their abbreviations, which is what you probably know better. Sine is abbreviated SIN. So sine of an angle, theta represents an angle in math, is equal to the opposite side over the hypotenuse. So this is where we get the little abbreviation SOHCAHTOA.
I wish I could get high on
COS, so cosine of theta is adjacent side over the hypotenuse. Okay, and then tangent of an angle is the opposite side over the adjacent side. So if you know those, so SOHCAHTOA, then you can find their reciprocal. So remember the reciprocal of a fraction, if you have like 2/3, the reciprocal is where we flip the numerator and denominator. So the reciprocal trig functions are where we flip the ratio. The reciprocal of sine is called cosecant. Now this is weird because the cos don't go together. We have a cosine and we have a cosecant, but cosecant is the reciprocal of sine. It is abbreviated CSC, cosecant. It is going to be the reciprocal of sine. So instead of opposite over hypotenuse, cosecant is hypotenuse over opposite. Do you see how we just took the reciprocal? The reciprocal of cosine is secant, which is abbreviated SEC. And again, this is of an angle. We forgot to put that on cosecant. So we take the reciprocal of cosine, which instead of adjacent over hypotenuse will be hypotenuse over adjacent. And then the reciprocal of tangent is cotangent.
Why don't they just like switch the words for cosecant and secant?
I know, like it would be so much easier, but unfortunately, that's not what it is. I'm a big proponent of labeling your triangles because I think it makes things a lot easier. You will always be given a theta, like your reference angle that you're using to find all of these ratios. The hypotenuse is always the side across from the right angle, always. And it is always the longest side. So the hypotenuse will be across from the right angle, and it will be the longest side in the triangle. The opposite side is the side that is opposite your theta, so your reference angle. And the adjacent side will be the one that is making part of that angle theta. So it is helpful to label those when you're working with these trig ratios. Okay, also just know that tangent is the same as sine over cosine. And then cotangent, if we flip that because it's the reciprocal, cotangent is cosine over sine. So those are just a couple of side notes. We have this triangle, and we are given an angle theta. So that's our reference angle there. And let's say we have 2 sides. And it's going to ask us to find all of the trig ratios. The first thing that I want to do is I want to label my opposite, adjacent, and hypotenuse so that I can easily plug these in to my ratios. This is my hypotenuse across from the right angle. 5 is going to be my opposite side. And 12 will be the adjacent side to my angle theta. I don't have a measure for my hypotenuse. It didn't give me one. How do I find it? Pythagorean theorem. Remember, that is how we find the third side of a right triangle. So you will be given a triangle that doesn't have a third side. But you can find it because we know that a squared plus b squared is equal to c squared. And c squared is always your hypotenuse. Okay? So a squared would be 12 squared. B squared is my other leg, so 5 squared equals c squared. So we get 144 plus 25. Okay, so what is it, 169? Yep, and so square root of 169, c is equal to 13. So this side over here, this hypotenuse is 13. Now we have all three sides. Now we can easily find all of our ratios, okay? So if we just go back over here. Okay, sine, remember, is opposite over hypotenuse. So we'll take the opposite side, which we have labeled 5, over the hypotenuse, 13. Cosine is adjacent over hypotenuse. So adjacent side is 12 over the hypotenuse, which is 13. If you ever get fractions that you can simplify, you must simplify them. These don't simplify anymore, but and then tangent is opposite over adjacent. So the opposite side is 5 over the adjacent side, 12. Okay, and then we'll do the reciprocals. We just need to flip. It's easy if you have these all set because you just take the reciprocal of the ratios you just found. So cosecant is the reciprocal of sine. So instead of 5 over 13, we have 13 over 5. Secant is reciprocal of cosine. So we flip the cosine ratio. And then tangent, or sorry, this should be cotangent. That's like a continued typo throughout this whole packet. Okay, so those are my 6 ratios. That if you see it, you must rationalize the denominators. And again, this is coming from geometry, and we did it in Algebra 2. You cannot leave a root in the denominator. So if you are doing these ratios and you have a square root in the denominator, you cannot leave it there. It's not simplest form. So in order to rationalize, we multiply. So if I take this, to rationalize, we will multiply both the numerator and the denominator by whatever that root is in the denominator. And then multiply straight across. On the top, we get 3 root 2. And on the bottom, if you multiply a square root by itself, if you square a square root, it leaves you with the radicand, so the number underneath. So this is the correct form for your answer, not this. Okay? So you have to rationalize if it comes up. Okay? Okay, so what I did is I changed this a little bit. Number 3 is what we're going to use for that blank triangle there. So it says if cosine theta equals 2/5, find all the values of the remaining trig function. Okay, so let's label our angle theta since it's not labeled for us. Let's put it down here. If this is theta, and we know that cosine is 2/5, what can we label in this picture?
Cosine is secant.
What's cosine?
Adjacent over hypotenuse.
Okay, so we can label the side adjacent. Let's label. Here's adjacent, here's hypotenuse, here's opposite, right? All with relationship to that angle theta. We know that theta, or that cosine is adjacent over hypotenuse, and we know that the adjacent side then, because they told us it was 2/5, the adjacent side is 2, the hypotenuse is 5. How do I find the opposite side? Pythagorean theorem. Okay, hypotenuse squared, so 5 squared is equal to 2 squared plus that missing side. Whatever variable you want to give it. Okay, so we get 25 equals 4 plus x squared. and then subtract 4. And then we get 21 equals x squared. So x equals what? Root 21. That does not simplify. If your radical simplifies, you must simplify it. And then let's go from here. So we know cosine already. We know that cosine was 2/5, so we can fill that one in first. We also know that secant will be the reciprocal of cosine, so we know that that's going to be 5/2. So we can do those two right away. And then, of course, this typo. This should be cotangent. Okay, so sine is going to be opposite over hypotenuse. Our opposite sign is root 21 over the hypotenuse, which is 5. Do I need to simplify any further? No. And then tangent is going to be opposite over adjacent. So the opposite side is root 21 over the adjacent side, which is 2. Can I simplify further? No. Okay, then we need to find our reciprocal. So we take sine to find cosecant and we flip it. We get 5 over root 21, which we cannot leave like that because we can't leave the root in the bottom. So we need to multiply top and bottom by root 21. So in the numerator, we get 5 root 21. In the bottom, in the denominator, when you square a square root, you are left with the radicand. And that is simplest form. Okay, same thing with cotangent. When we take the reciprocal, we're going to get 2 over root 21. And then we have to rationalize. So cotangent is going to be 2 root 21 over 21. I'm going to change this slightly. I'm going to change number 4 because I don't love it. But you need to have memorized the rules about special right triangles and the relationships of the sides of special right triangles to their angle measurements because they all follow this pattern. So 30, 60, 90 is the first type of special right triangle where one angle is 30 degrees, one angle is 60 degrees, and obviously because it's a right triangle, one angle is 90 degrees, okay? With special right triangles, they all follow this pattern. The side opposite 30, we are going to call x. Okay, the smallest side, the side opposite 30 is always the smallest side. The hypotenuse is always twice as big as that smallest side. And the side opposite 60 degrees is always smallest, x root 3. X root 3 is always the smallest side times the square root of 3. For example, I'm going to erase these. You guys can just do it down below. Hold on, because I want to just do this different. I want to do a little bit more practice on this rather than on finding more trig functions. Okay, so for number 4, let's say if we had a special right triangle that was like this. So we've got our little right angle here. We've got our 30, and we have our 60. So if we have our sides, let's say that they told us that 60, the side opposite 60 is the square root of 6. Okay, and then it's going to ask us to find what is the hypotenuse. What should I call this? I'm just going to call it a question mark. So that's what we're trying to find. We don't have two sides, so we can't just use Pythagorean theorem and say x squared or a squared plus b squared equals c squared. What we have to use is the principle of these right triangles. So if we know that the side opposite 60 degrees is always equal to x root 3, can we solve for x?
Sure.
Yes. We know that this side opposite 60 degrees, do you see how it's also this? We know that the square root 6 has to equal that ratio, right? And we can now solve for x by just doing algebra. So if we divide both sides by the square root of 3, we're going to solve for x. Remember that with square roots, we could keep them separate, or we could do this and put it as one fraction. 6 divided by 3 is, right, so x equals square root of 2. But we were not asked to solve for the x side, but we know what it is now. That short side is square root of 2, meaning my hypotenuse is always the short side, which was this, times 2. 2 times what we found was that x value. And that is the length of our hypotenuse. So knowing these rules of special right triangles will help you solve when you don't have a third side for Pythagorean theorem. Okay, it's going to be an isosceles triangle because both of our angles are 45, so these legs are going to be equal. And the ratio of sides in a 45, 45, 90 triangle, each of the legs we are going to call x, and they're always the same. And the hypotenuse is going to be equal to that side times the square root of 2. Always. So if we have something like this, so if I give you a triangle, I don't know, like this. Yikes. We're going to call this a right triangle, even though it looks really bad. But that's our right angle. And then they give us this, and we need to solve for that. What is the length of the sides in this 45, 45, 90 triangle? The way you'll know it's 45, 45, 45, 90 is either that they give you an angle or that they draw those symbols, meaning the sides are the same, or that they draw these symbols, meaning the angles are the same. So you might see it represented any of those ways to know that it's a 45, 45, 90. How are we going to solve for x? What do we know about the hypotenuse? Yes. We know that the hypotenuse, that's opposite side of the right angle, must equal x root 2. So we know the length of the hypotenuse is 9. So we'll say 9 equals x root 2. And then to find the length of the side, we just need to solve to get x by itself. So first, divide both sides by the square root of 2. So that we get x by itself. So we end up with 9 over the square root of 2. We cannot leave it like that. We have to rationalize that denominator. So we'll multiply top and bottom by the square root of 2. And we get that short side x equals 9 root 2 over 2. Use trig functions to find missing side lengths. Sorry. I'm going to keep saying this, even though almost everything we're doing is right triangles right now, but just remember you cannot use SOHCAHTOA if it's not a right triangle. So we can use trig functions to find missing side lengths when you know a side and an angle, but need another side. So be careful. Make sure you always read where you're supposed to round, because this is where you're going to use your calculator. And so you'll a lot of times get long decimal answers. So you need to read where you need to round your answer off to. So let's start with letter A. We are finding this missing side x. This is not a 30, 60, 90, so we're not using those special right triangles. But this is our theta reference angle. So if I label all of my sides, I have the hypotenuse here, I have an opposite side, and then I have my side adjacent to 68. So given that I have an opposite and a hypotenuse, what trig ratio should I be using to solve this? Sine, right? Sine, opposite, hypotenuse. So those are what I have. So I'm going to say the sine of 68 degrees equals opposite, which is 96, over my hypotenuse, which is what I'm trying to solve for, over x. Okay, you need to make sure your calculator is in degree mode. You'll see it along the top of your calculator when you turn it on. If it says radian, you need to go into mode and switch it to degree. Okay, so to get rid of this x in the denominator, we have to multiply both sides by x. And then we get x sine 68 equals 96. And then the last step to get x by itself is we divide both sides by the sine of 68. So then our answer is 103.539. It tells us to round to the nearest tenth. So we go to the tenths place, which is here. Look to the right. So it's going to stay 103.5. And that is our answer. Okay. Letter B. Looking at our reference angle, it's down here. And labeling our sides, we have an opposite, we have an adjacent, and we are not given a hypotenuse. So if we have an opposite side and an adjacent side, which trig ratio should we be using? Tangent. So we're going to say tangent of that angle, which was 70 degrees, is equal to the opposite side, which was 8, over the adjacent side, which was x, which is what we're trying to solve for. And then just use algebra. To get rid of the x on the bottom, we multiply both sides by x. So we get x tangent 70 equals 8, and then divide both sides by tangent 70. Oh, sorry, this was supposed to be 8. Yeah, so x equals 2.911. To the nearest tenth would be 2.9. Okay? The biggest suggestion I can give you with everything trig is to draw. So draw out your word problems, draw out your triangles, label your sides, because that's going to help you keep things straight and give you less of a chance of making a mistake. So we need to talk about these vocabulary words in terms of labeling angles when we have a word problem. You have to be super careful that you label your angle correctly, otherwise you're going to get wrong answers. So an angle of elevation is an angle formed by a horizontal line and a line of sight to an object above. So elevation goes up, from the ground up. So it would be something like if you have a person and they are looking at, like, whatever, a balloon. That is the, like, ugliest balloon. Actually, I don't want to draw a balloon. Okay, let's just say to the sun. Okay, your angle of elevation is formed by the horizontal distance and the angle that is going up from the person to that object. So this is your angle of elevation, okay? From an object on the ground to an object that is higher up, versus an angle of depression, which is formed by a horizontal line and the line of sight to an object below. So this one is the tricky one that we sort of sometimes incorrectly label. So you have to be super careful. This would be like something like if you have an airplane and it is looking at like a boat or something like that, okay? And you are asked to, you're gonna have to solve a triangle or whatever. The angle of elevation is formed by the horizontal line from that object to the object below. So this is your angle of depression. Yes. It says Charlotte wants to use a sheet of fiberboard 34 inches long to create a skateboard ramp with a 20-degree angle of elevation from the ground. How high will the ramp rise from the ground at its highest end? Round your answer to the nearest tenth if necessary. So draw it. If we draw it, we know that her board is 34 inches long. And we know that it forms an angle with the ground, which is horizontal. And the angle is 20 degrees. So it is asking us how high is the ramp. So if we connect these lines, this is what we're looking for, the height of that ramp above the ground. Once we have our sketch, we can label our sides. We have a hypotenuse because this is a right angle. The ground to that height is perpendicular. So we have our hypotenuse, we have a side that is adjacent to 20, and we have a side that is opposite. So we're looking for x, and we have 34. Which trig ratio should we be using? We have opposite and hypotenuse. Good, so we're gonna use sine of 20 equals opposite over hypotenuse. So x over 34. To get x by itself, I multiply both sides by 34. And this is what I put into my calculator. 34 times the sine of 20 degrees, which gives me 11.628. It told me to round to the nearest tenth, so I should say 11.6, and we are talking about inches, so you need to label your answer. Okay, here's another one. This is angle of depression, so we have to be careful with our labeling. It says from the observation deck of a skyscraper, Bentley measures a 48-degree angle of depression from a ship or to a ship in the harbor below. If the observation deck is 969 feet high, what is the horizontal distance from the base out to the ship? Round your answer to the nearest tenth. Okay, so let's sketch this. We have the skyscraper, which we'll call over here. And he is looking down at a ship in the harbor below. The angle of depression is from this horizontal line at the top to the ship, and it is this. That is our angle of depression, 48 degrees. Now that does not fit into the triangle that we need because they're asking us for this value. What is that horizontal distance from the skyscraper to the ship? So we need to figure out how to get 48 into that triangle. There are two ways to do this. Number one, this is a big right angle, right? Because those would be perpendicular, the line of sight and the skyscraper. So we could do 90 minus 48, and we could put that in our top right corner or top left corner of our triangle. Or the other thing we know is that essentially we have two parallel lines that are cut by this transversal. Do you see that? The other thing we know about that, again, going back to geometry, is that this angle down here, when parallel lines are cut by a transversal, opposite angles, or whatever you call those, opposite interior angles, are congruent. So this is also 48. Okay? Once we have that, this is our right angle. We also know that we haven't labeled yet that the observation deck's height is 969 feet. So we can label that skyscraper. And then if we take a look at what we have, we've got an opposite side. This is the hypotenuse. And we have our adjacent side. So we have opposite and adjacent. Which trig ratio should we use? Tangent. So we're going to say tangent of 48 is equal to opposite over the adjacent, which we need to find. So then multiply by x. And then divide both sides by tangent of 48. And when we do that, our calculator gives us 648.387. Oh, did I do it wrong? Hold on. Okay. I'm not sure what I did. 872. Yep. To the nearest 10th, 0.5. And this would be feet, which is the distance from the skyscraper to the boat in the harbor. Try number 8 on your own. 26-foot ladder, angle of 78 degrees with the ground. So this looks like this. And then it's asking us for the horizontal distance. So we are looking for the ground length, essentially. If 78 is our theta, we have a hypotenuse and an adjacent. So hopefully you used cosine. Cosine of 78 degrees is equal to the adjacent side over the hypotenuse. Then we'll just multiply both sides by 26. Put this into our calculator. We get that x gets 5.405 to the nearest hundredth. Be careful, this one changed. And this is an example of what you will see in Delta Math, so you need to watch. Hundredth is 2 places out. So this would be 5.41 feet. So read where you're rounding. We can also use inverse trig functions. So far we've been finding sides, missing sides, but we can use inverse trig functions to find missing angle measures. So if we need to find an angle measure and we have sides, we can use the inverse trig function. So you use this when you have side measures, but need to solve for an angle. So what this looks like is like number 1. If we have a triangle and it's a right triangle, meaning we can use SOHCAHTOA, we can use those trig functions, we are asked to solve for this angle. So again, we want to use that as our reference angle. This is our hypotenuse, this is our opposite, this is our adjacent. If we have an adjacent and an opposite side, we will use tangent. So what we're going to say is tangent of x, because we don't know the measure of x, is equal to the opposite side, 5.5, over the adjacent side, 4.2. To get x by itself, to solve for x, we take the inverse tangent of both sides, which is this. And we are going to take the inverse tangent of both sides because that is the inverse operation of the trig function. The buttons for these are right above your sine, cosine, and tangent button on your calculator. So what you're going to put in is it's going to look like this. X degrees equals inverse tangent, in parentheses, 5.5 divided by 4.2. So we get that x equals 52.633. It tells it to round to the nearest tenth, so we'll say 52.6. It's an angle measure, so it is in degrees. So let's set this one up. Here's our theta. We're looking for that angle measure. We have an opposite and we have the hypotenuse, meaning we should use sine. So we're going to say sine of x is equal to opposite over hypotenuse. To get x by itself, I need to take the inverse sine of both sides, because that's going to leave me with x equals inverse sine of 3.3 over 4.2. So it gives us x equals, be careful with your rounding because what it actually says is 0.786 if we are rounding to the nearest tenth, that rounds up to 51.8, and it's an angle, so we say degrees.